All right, are we ready to start?
Yes.
All right. All right, thank you so much. Welcome everyone. Good morning or good afternoon, good evening, wherever you are. It is my pleasure to introduce DataJoint workflows for neurophysiology, our workshop. There'll be several presenters. I will start with a quick introduction and overview. Please feel free to ask questions anytime in the meantime. My name is Dmitry Yatsenko. I'm the CEO of DataJoint, and we'll go from here. All right. So first, let's talk about some typical neurophysiology experiments so that we know what type of problems we're addressing. And these are, I will show a few examples where DataJoint was used and that were actually milestones in the development of DataJoint as well. So modern experiments are highly multimodal. In a typical experiment, like in this from Jay Creamer, you will use many different modalities all at the same time, or in the same study, there could be a dozen different modalities, such as calcium imaging, electrophysiology, behavior, pupil recordings, brain state recordings, locomotion, and then visual stimuli, perhaps electrical stimuli or whisker, a lot of different types of modalities that all need to be synchronized, and the amount and complexity of data is can be staggering. And so typically students and postdocs must perform these feats of data engineering, how to combine all the data. And as complexity and sizes of data grow, then you end up spending more and more time and a bigger fraction of your effort on moving and translating, aligning, and handling the data. So here is another project. It's called Microns, Machine Intelligence from Cortical Networks. In this study at Baylor College of Medicine, mice were observing visual stimuli, and about 1 million neuron hours of data was collected from while these mice were observing, watching videos. And then in this volume, the image volume, a cubic millimeter, then was also imaged in an electron microscope at the Allen Institute. And so we have the complete functional description as well as anatomical description. And then a reconstruction of the overall network was performed at Princeton University. All the anatomical, all the synapses, all the membranes, vesicles, you can see everything in these data sets. And so the core of this data set was recently released after many years of collecting and aligning and curating the data set. So you can see the data on microns.datajoint.io and can actually explore it interactively. There are a lot of findings in these data. So the team who acquired it, we've only begun to really analyze the interactions between function and anatomy in this data set. Another type of studies are closed loop experiments. This study where also DataJoint was used, it's called inception loops, where experiments for the following day are driven by parameters or model parameters fitted to the data from the previous day's experiment. And this was a distributed study where the data were acquired at Baylor College of Medicine, but analyzed in Germany at the University of Tübingen. So DataJoint provided that data infrastructure to automatically analyze the data and also to make it accessible to all the collaborators, distributed collaborators that work jointly. This is I see this as one of the major trends in neuroscience toward closed loop experiments. And this reminds me of the concept that's currently gaining momentum in industrial design, the concept of a digital twin, where a virtual counterpart of a complex system is maintained in parallel. And you can do fast iterations of experiments and modeling using the physical object. In our case, it's the brain, in a model of that. In this case, it's an artificial neural network. And so you can use the model to make predictions and to accelerate the pace of discovery from the brain. So another project in which we are currently participating is the studies of thalamocortical organoids. So these are human organoids from human patients. And organoids are little pieces of brain tissue, and they form complex network that actually have brain activity. And so you can study their genetic makeup, you can study their electrophysiological properties, and also imaging in these highly multimodal studies. So, and just to give you some numbers, one of the currently emerging or rapidly gaining momentum technologies is NeuroPixels, the NeuroPixels probes. NeuroPixels 2.0, a single implant has about 10,000 or has 10,240 recording sites, and you can record from 768 channels at a time. And in many experiments, you would insert several of such probes in one animal. And so just from a single probe, you would be recording at 30 kilohertz, you would be recording about 154 gigabytes per hour. So in a typical study, say if you record overall to support your scientific finding, you record 2,000 hours of the implant recordings, that will amount to 300 terabytes of data, of raw data before spike sorting. So, and this is not about to slow down. This is another study in which we use DataJoint. It's a pure simulation study of a proposed modality called neurophotonics probes. And in these neurophotonics probes, potentially the raw data will be on the scale of 10 terabytes per hour. So things are about to get even more complex. So what's the problem? The way currently most labs operate. These are the types of operations that would require an enterprise, really a data center to perform with engineers and technicians. And in most cases, this is done over and over by postdocs and graduate students. And a lot of the steps are reinvented over and over. And then at the end, sharing data and sharing this learned experience, these workflows is not trivial. And so this impedes reproducibility and also efficiency of science. So what we have been working on is the concept of scientific workflows and automated scientific workflows and scientific workflow management. So a scientific workflow is a multi-step process for data collection and analysis. And we emphasize that this is the scientific workflow management systems manage data in the active phase of the experiment, not sharing data after you are done, once you package and share it with the community, but while it's being collected and many people are accessing it at the same time for both reading and writing. So DataJoint workflows combine manual steps for data entry, they combine data management in a database, and also automated analysis. And there are three components to it, and so we'll discuss each one of them. DataJoint itself is a software framework. It began as an academic project. It's open source, and we are committed to follow the best practices of open standards and develop this into a component of the overall data science infrastructure. DataJoint Elements is a funded project, a U24, NIH U24 project. We're currently in year 2, and this aims to produce specific workflows for neurophysiology experiments. And so you can go to elements.datajoint.org. And in the first year, we rolled out 3 workflows, and we will focus very much on one of them, the electrophysiology workflow. And then in year 2, we're focusing on behavior, on trial-based experiments, and so forth. And DataJoint SciOps is our managed service. So all these solutions are free, open source, and they can be deployed and reproduced in each lab on their own infrastructure. But to allow more labs and to make it easier and quick for labs to adopt and use these solutions, we also offer a fully managed service as a paid service. Where our team, our engineering team, manages them efficiently, executes them so that scientists can focus on the experiment side of things. And so let's introduce some concepts to make sure, because database, the word database is most often used kind of loosely. It's just any collection of data is called a database. But here we're talking specifically about structured data serving as an integral part of your process. So you're, in this case, a scientific study. So it's the backbone, the data backbone that needs to be accessed by many people, accessed by many systems, especially if you have distributed computing, if you have very computation intensive operations. Now, something that databases provide that other systems don't, like a simple file repository will not guarantee data consistency. So data consistency is a compelling illusion of a single copy of the data that everybody can read and write at the same time without introducing conflict or loss of data integrity, data corruption. So we talk about workflow. So workflow also is a technical term here. It's basically the multi-step, any multi-step repetitive process that you do every day. And we need to capture them formally because this is what makes a lab. The biggest asset in any lab is its operational workflow, how all the steps that are required. And we only capture the computational part. Of course, to run an experiment, you have to do a lot of other things like surgery and pulling pipettes and preparing electrodes and doing all of those things. So DataJoint is also a formal workflow management system, and there are many, many such systems. The unique role of DataJoint and why it's gained momentum in neuroscience is that it also structures data in the database. So it combines both databases and workflow management. So what do databases? So if you are like most scientists, you don't use data, most labs don't use databases in their day-to-day operations. So in many cases, you don't need to. If you're just working by yourself, if your process is not sufficiently complex to warrant the use of databases, just using a file system with just storing files, collection of files, if you don't need to navigate them quickly, you don't need to query them, it's fine. But at some point, you will need a more formal process for managing data. And so databases provide and enforce for structure, and they enable concurrent access by multiple participants. This is where databases become critical when there are many different players, many including humans and including computational agents that all have to access the data from different perspectives and different views of the data. Data consistency and data integrity. So we mentioned it already, so that there needs to be structure, everything needs to be clearly identified and matched and complete. While people are accessing things simultaneously, their simultaneous transactions should not introduce loss of data integrity. Flexible queries, and here we mean fast queries, so you need to be able to get arbitrary cross-sections of the data very quickly. So these are standard databases. What DataJoint does in addition, it also combines as a native part of the data model, workflow management and automated computation. So how does that work? So basically we use the relational data model and the relational database backend, but it's programmed directly from MATLAB or Python. And all the computations are automated through MATLAB and Python. So you can create complex dependencies, computational dependencies directly in MATLAB and Python and have them automatically executed. So some of the basic concepts. A database is a collection of tables, and each table corresponds to some element or some entity in your experiment. For example, one table could be a mouse, another is an imaging session or a recording session, and then you might have something like a neuron. This is a very simple workflow. Real workflows are much, much more complex, and we'll see some examples. And then some of the nodes are manual, so they're for data entry during the experiment, and they may be associated with a GUI, a web GUI to enter and navigate the data. And some are automated, and for example, extracting spikes from a recording or performing some analysis, it's an automated step. So what workflow management does for you is that you don't have to repeat manually all the repetitive computational steps. So here's DataJoint in a nutshell. There will be a lot of training in this during the next couple of hours and the next 3 days to explain this in detail. But basically, a workflow is a directed acyclic graph. It's a database where each node is a table in the database, and also it's a class in Python or MATLAB. And then the dependencies between them show both data integrity, what depends, basically data dependencies, but also the direction of the workflow. And that's what's used to automate the computations. So what DataJoint provide is simple database programming. It allows you to define the structure of the database. It also has diagramming notation, so you get these beautiful diagrams. And you can query the database directly from MATLAB or Python straightforwardly. And then it automatically, so some classes have this make method, which is basically the computational step that needs to be performed. It also provides, and then the framework automates these computations. It also provides data serialization. So something that databases have a hard time typically is working with complex scientific data. So DataJoint streamlines, or basically serializes, converts data for storage in the database and then recovers it. So you can store a numerical array, a time series, or a movie directly in the database. So as you work with DataJoint, you don't work typically with files. People are data scientists, neuroscientists are very much used to working with files. But when you work with DataJoint, when you fetch an object, it doesn't come as a file. It comes directly in memory as an object. And as you automate the workflow, you basically want to the framework to handle common situations, things like fixing an error. How do you propagate that all the changes are propagated? It keeps track of all the parameters of the computation, so you know what was computed with what. It's sometimes described as provenance. And if you fix a bug, for example, you need to propagate all the changes correctly so that then it also supports this operation. If you need to try a new analysis, you can have a new method. For example, if you have a new spike sorting method or a new analysis, some variation, you can keep multiple versions and then compare them and decide which one works best for you. And then if any interruption does not cause corruption or incomplete data or anything of that sort. So if you break out of a computation, then it's rolled back, any partial results are rolled back. This is something that if you do this directly, programming in MATLAB or Python directly without a framework to manage all these computations, this takes a lot of thinking and organization. So a little bit of history. So DataJoint began as an academic project, more of a personal project to support my own experiments about, quite a bit ago in around 2009. But then other people in the lab started using it. And then I was in Andreas Tullia's lab. About a year later, Andreas asked all other people to use it as well. And then it spread to other labs as well. And around 2014, other people in the lab began contributing. Especially, we started building the Python version So this is just a snippet from the 2011 version of the documentation on the right side. So kind of a flashback of what it looked like back then. And in 2016, we got an SBIR grant, Small Business Innovation Research Grant from DARPA to commercialize DataJoint, to basically create services, consulting services, and also hosting services so that labs can use it more efficiently. And we've been, as a company, we've been involved with a lot of large-scale projects, but this is not to take away from that. DataJoint is pretty simple, and people can, I use it for very small projects as well. So because big labs hire us and use our services doesn't mean that DataJoint cannot be used for small projects. So we need to highlight that as well. And so in 2020, we started our U24 grant, DataJoint Elements, and the website datajoint.org will contain all the open source tools. And in datajoint.com, we just recently launched it. These are the standardized services based on, so that if you have a typical neurophysiology experiment, you don't need to develop things from scratch. A lot of solutions already exist, and so you can quickly deploy them. So a typical architecture for DataJoint uses a centralized database. So the data acquisition from the acquisition system typically streams to some raw data recording system, and then automated ingestion, ETL, extract, transform, load scripts are run to populate the database with the raw data, and then with the initial data, and then the rest of the pipeline is executed automatically by some number of nodes that sit there and wait. So you can set up. When I was doing this for my own thesis in the evening, I would just go to all the experiment acquisition computers and just run while they're not being used for experiments, and I would just use them to run my analysis. And so they all talk to the database, and I was able to streamline all the computation. My thesis was very computationally intensive. And so now increasingly, projects have visualization interfaces on the web, so that they can, all the team members can see what's happening, review the quality of the data. The PIs really like it because they can see the current status of each project, so that for many projects, they view the web visualization as the most important component. So what the DataJoint enables you to do is to share the data during its active phase in the workflow, in the acquisition. So you can have multiple people. So this is how the International Brain Lab, for example, works, with 22 labs working together, and it all goes into a common pipeline. And the shared data pipeline in DataJoint allows sharing the data without introducing any sort of race conditions or corruption or anything of that sort. So that's describing DataJoint Elements, this preprint and bioarchive. And so if you start larger projects, you have to solve these distinct areas that are best solved by people who specialize in them: IT infrastructure, data engineering and operations, data science, and experiment workflow. So the scientists work on the workflow, actually entering the data, pushing it through the analysis, pushing it all the way to generating visualizations. Data science creates the actual analysis. It figures out what tests and models to use, what pre-processing steps. Data engineering is just about moving things around, converting, making sure that everything matches. This is where DataJoint, the framework, that's what it automates, and it maps onto the existing IT infrastructure, which can be, usually it's institutional IT, or increasingly labs and projects use cloud platforms. And we now provide a fully managed solution from the company, so that you can just opt to host, and we'll completely manage the hosting and the operations of the workflow, so that you can focus on the data science and the experiment for the most part. Okay, and so these are some of the big projects we just added a couple more. I'll talk about them. We've been working on these for several years, for example, with the MAP, the Mesoscale Activity Project, started in 2017. We're still working with the 4 teams that are part of this project. But the International Brain Lab, we've been working with them since 2018, and they use DataJoint to organize their computational workflows and several others. So this is a more complete list. So, but a lot of labs use it without our direct involvement, because these are open source tools. So highlight in green are the labs we're working with directly, but or we have worked directly with. And a lot of labs, we actually don't currently track the exact usage, how many people are using it, but we will improve that and basically collect some feedback more systematically. But a lot of labs have used DataJoint to organize their collaborative projects. So DataJoint Elements is the effort to produce specific implementation. DataJoint itself is a general framework. DataJoint Elements are the specific implementations for neurophysiology. So in year 1, we developed these 3 workflows: array electrophysiology, really focusing on neuropixels, and this workshop will be focusing on the analysis of electrophysiology data. We've also developed the playground infrastructure, the online infrastructure, where you can without setting anything up, you can just go and in the browser analyze data, use DataJoint in Python through Jupyter, the Jupyter infrastructure, Jupyter notebooks. We also created DataJoint Labbook, which is a web interface for entering and navigating data in DataJoint pipelines. So it's a general interface. Everybody needs a graphical user interface to interact with the data, so this is what we implemented. We provide support for labs that want to, as part of this funded project, for labs that want to adopt and set it up in their own labs. We can work with them directly and help them set up. In year 2, we're focusing on electrophysiology, and tomorrow I'll go into a lot more detail, the future projects. And so so right now we just accommodate basic spike sorting. In year 2, we'll add all the synchronization. So every lab, many different labs use different synchronization schemes. If you have several recording modalities, you have to put them, synchronize them to the same clock and align them with trials. So these are what these elements will help accomplish. And we'll also add sensory stimulation, things like visual stimulation, air puffs, and then also histology to restore the probe trajectories for electrophysiology. So this is just a preview of, actually I'll go back. One big effort is to also to create the training infrastructure and to prepare materials. This is part of this effort. We will start doing these training sessions regularly, every year at least, with INCF, but also with other venues, including Neuromatch Academy and Society for Neuroscience. And we're also working on integrating with Neurodata Without Borders and with Dandy Archive, so that publishing data would require very little to no effort. If you organize your data in DataJoint, then exporting it to for sharing outside the project should be straightforward. This is just a snippet from one of the DataJoint elements for electrophysiology. You can see that it's a bit more complex once you introduce the actual complexities of clustering and LFP, and curation is a big part of the process. So during the workshop, we'll go in detail through these steps. This is calcium imaging. There are steps like segmentation to extract fluorescent traces, and then activity to convert these fluorescent traces into spiking activity. And we follow a thorough process for selecting projects for support in DataJoint Elements, and also to assure good software engineering quality. It's an open process, so that we have a scientific steering committee to take input from the community to ensure that this meets the current demands and that it doesn't overlap with other projects, and so that it delivers high value to all labs. So we also provide, as a part of sustainability roadmap for DataJoint elements, we provide services to run them, to actually manage and execute the workflows by our team. So the way this looks is that the teams, if they just want to follow a typical standard pipeline workflow that has been developed in other labs for things like calcium imaging, then they can just acquire the data, enter the information, and then it's automatically processed, and then they have access to the process data for further analysis. And then we support collaboration and publishing so that we can provide access to multiple team members. So this is our whole team. We have a neuroscience team. So our team, these are experienced neuroscientists who work with a lot of different modalities, including human, including MRI, but also all modalities of neurophysiology and behavior. And we also have a software and data systems teams and business operations as well. I would like to particularly thank our scientific steering group that provides us with guidance. We meet twice a year, and they provide input on the priorities in the field, on what modalities are required the most attention. And with this, thank you very much. And if you have any questions, this is a good time to ask. All right, well, if we don't have any more questions, Pradeep, do we have any questions? If not, then we'll, okay, I see the chat.
No questions from the chat.
Okay, all right. Okay, then we'll take a break and we will resume with the actual training session. And David, would you tell us when we get back?
Hi, good morning, everyone. Yes, so our training session, I'll be linking it in the chat. And so if we haven't had a chance to sign up, let me put the video on. If we haven't had a chance to sign up, we can sign up there. So it's going to be INCF 2021. DataJoint.io. Let me get the immediate link here.
Okay, so and when should we get back to
so
okay.
Officially we start at so officially we start at 11.
Okay.
Yeah, so Pradeep, is there a preference if
No, it's absolutely fine.
Okay. Sure.
So how long we have the break? Just to
let's just take a 10-minute break and we can continue.
10-minute break, yeah.
Yeah.
Okay.
So
Let's
start at 10:45, and if we get done earlier, that's great. Okay.
Right.
Yeah.
All right. I'm stopping my share.
Okay. Thank you.
Thank you. And as I said before, guys, we can all sign up at the link. It's incf2021.datajoint.io. And so that's where we're hosting all our training materials. And it's where you guys can get the full hands-on experience. But we have about 10 minutes to sign up if we haven't done so. And we'll be back at 10:45 Central Time. All right, Pradeep, are we all there? Can you guys hear me?
Hi, David. Yes, we can hear you.
Hey, thank you, Kavi. All right, Pradeep, are we all there? Okay, let me see something. I have an intense echo. Oh, okay, I know what it is. Can you guys hear me? All right, yes. All right, so Pradeep, we're gonna start. Let me just do a quick check. Is everyone else here? All right, awesome, thank you. Awesome, so we'll get started. Good morning once again to everyone. My name is David Godinez, and I am a data engineer here at DataJoint. And it is my, thank you, Julian. It is my honor and pleasure to be working on this, to be teaching you in this workshop. So we're starting a bit early, so of course we'll finish a little early. But I hope that at the end of it, you guys walk through a solid understanding of what DataJoint is and how to use, or how to at least get started using the DataJoint framework. So I'm going to share my screen here. Let's see. All right. And so if you haven't had a chance yet, I've linked the address to our workshop website, to our workshop site. It is INCF 2021.datajoint.io. So you'll be, if you don't have membership just yet, you'll be prompted to sign up for a DataJoint account. And you'll be able to log into our workshop site and look at the materials. Are we pretty much set up, or do we need a bit more time to get set up? Just let me know in the chat, please. All right, thank you, Mia. I appreciate it. Thank you, and I love that we're getting people interacting. The point of this workshop is to be interactive. Thank you so much, Julian. The point of it is to be interactive, and we're gonna get our hands dirty. If you have questions, feel free to ask in the chat. It's definitely going to be a back and forth. And the more interaction, the better, okay? So please don't be shy. And we're here. And we have a great team as well. We have myself, Dimitri, and Kabilar. And so, we're all here to answer any questions. So if you've signed up for your account, you would see a couple directories that look like this. Please go to the one that says workshop, and please click on the one called 00 getting started. And just let me know when you're there so that we can get started. Awesome, awesome, thank you. So this is our DataJoint tutorial. Welcome once again. And as Dimitri said, in research, we have a few problems, right? Or major kind of problem statement. And the first is that research teams must manage big data and complex computations with limited engineering resources. The other problem is that there is a lot of reinvention of solutions for automating this workflow. But, of course, you don't always want to be reinventing the wheel. You don't always want to, start from scratch, right? It's cumbersome, it's costly, takes a lot of time. And finally, the issue of sharing data, right? As you're working through your experiment, research, it's often entire research teams, often consortia, so different labs working together. And so there's always this need to share data. And so DataJoint offers a complete solution to that. And a part of that solution involves the DataJoint framework, which is the open source framework where, of course, it's free and it's available in Python and MATLAB. And so that's what we'll be going through today, specifically the Python portion of DataJoint. But everything that you see here is translatable to MATLAB. So if you're more comfortable there, we have a really, really great set of documentation. And it's available at docs.datajoint.org. So I'm going to link that as well in the chat. And so this is for the future, right? You can, like I said, you can read through the docs for Python, or you can read through the docs for MATLAB. The one that I've linked specifically is for Python, but the docs for DataJoint for MATLAB are also there. So in this notebook, our objectives are: 1, we'll learn how to import the DataJoint package. 2, we'll connect DataJoint to our workshop database server. 3, we'll learn how to save our connection configuration. And 4, we'll change our database password to something more secure and memorable to change it into our, and save it into our configuration, okay? So we have 2 notebooks that we'll be going through for today. It'll be notebook 00, and then we'll go through notebook 01. So first things first, so right now we're in Jupyter Hub, and for future reference, if as you're on your DataJoint learning journey, we do have what's called our playground. And so you can always go to the playground and you'll have this Jupyter Hub available, and we have notebooks where you can continue learning, you can practice, and it's hosted by us, by DataJoint. So, and the beauty of this, of Jupyter Hub is that, it has DataJoint, the DataJoint package pre-installed, along with many other popular scientific computation Python packages such as NumPy, SciPy, and Matplotlib. And so if you're familiar with Python, you'll know that whenever you want to import a package, you go to your cell and you import your package, and normally you'll have some alias. For us, we'll import DataJoint as DJ. So that's our convention. That's our alias. So DataJoint is DJ. So we can run this cell, we see that it's working. And since we didn't get any errors, Python wasn't complaining, we know that DataJoint was imported successfully. So now that we've imported DataJoint, we know that this framework, we know that one of the most important aspects of DataJoint and working with DataJoint is that we're interacting with data, we're managing data, we're sharing data. And so as you might imagine, the database is central, right? Is central to all our thinking, is central to our workflow. So now that we've imported DataJoint, we're gonna need to configure a few things, including the database. So right now we're gonna look at our first attribute here. So if we run this cell, dj.config, we see several different configurations. And in particular, we're going to look at three. One is showing up here, but we're going to input the other two in a sec. And so the first is database.host. And so right now, what our DataJoint config is telling us is that we're connected to tutorial-db.datajoint.io. And that is a database that is hosted by us for the purposes of this workshop. And it is also the same database that we use in the playground. So whenever you want to see your configurations, you can use the config attribute to see these different configurations. So of course, now we're connected to a database, but now we'll have to tell the database who we are, and we'll have to let the database know if we even have, if we even are supposed to have access to it. And the way we do that is providing DataJoint with a database password. So one way to do so is to type datajoint.config, and in your square brackets, you're going to type database.user to let DataJoint know who you are. So in my case, I'm going to let it know that I'm David Godinez. And this is my spare account, so don't worry. There is no hacking me, so I can put a password just for demonstration purposes. And so I'll put my database user, and I'll tell it that my password is presenter1, just right. So now that I've configured that, I've let DataJoint know, hey, it's David Godinez, and these are my credentials. So if I run dj.config, we see a couple more lines added, which is our password, presenter in my case, and we have our user, right? So now DataJoint knows, okay, this is our database, right? Tutorial-db. We know who it is, and we have the proper credentials. So in order to test this connection, in order to see if we're actually connected to our database, we're going to use dj.con. We're going to use the con. And as you might imagine, this method is short for dj.connect, right? So let's see. And so it says here, connecting David Godinez at tutorial-db.io. This is our port. So it was successful, right? If it wasn't successful, DataJoint would have complained. They would have said, hey, there's an issue here, access denied or some type of error. Let me know if you guys are following, if you have any issues, any questions, any concerns. We're here. All right. And so as we said, if the above call returned without an error, then you have successfully established a connection with the database server. So congratulations, you're pretty much in. Now, so one kind of caveat with our Jupyter Hub environment here is that our settings or our data, whatever we do inside this hub, we say that it is not persistent. So whatever you do in here, it's going to be reset after a certain period of time or whenever you log out, right? So if you were to, I know the first time I used it, it was late at night, and I kind of like left my computer on and I fell asleep, and the next day I woke up and I was logged out, and when I logged back in, all the changes that I had made were gone, right? So we know that whatever we do in here isn't persistent. So what we can do in order to save our configuration information is we can tell DataJoint, we can use the save local method. So this is going to save your configuration to Jupyter Hub and make it persistent. So now, again, if we don't see any error, we don't see DataJoint complaining, we know that no news is good news, right? In this case. So we know that our configuration was saved successfully. And if you would like to save this configuration globally, you could also do the save_global method, right? And so, of course, again, people who, if you're a bit more familiar with programming or Python, you know that anything that's global trumps local, right? So now we've told DataJoint, hey, I want you to save my configuration info for all the notebooks in this environment. If you decide, hey, before we move on, do we have any questions or do we have any concerns? All right, so much like I was saying, for right now, no news is good news. So I guess we don't have any concerns. All right. So if you decide that so it says here, the username and password used to connect to this tutorial database is that of your datajoint.io account, right? And so you can change this password on the datajoint.io website. There's also an easier way to change your password. And in order to do that, you use the dj.setPassword method. So let's say if I wanted to change my password, it says, yes, so this is particularly useful if you're using DataJoint outside this tutorial, where your DataJoint credentials are not used. So we could use this method if we want to change our password. And of course, well, right now I'm not going to change it, but yeah, if we wanted to, this is how we would do it. And then you would save your global config once more. So let's do our final check to make sure that everything is working. And so we see, yes, David Godinez at tutorial-db.datajoint.io. Awesome. So if all of the above worked, now you're ready to continue on with this tutorial. And so the next step in this tutorial is to learn the basics of DataJoint framework. So now we're going to go to notebook 01. And I'm just going to ask you guys to let me know when you're there. You can just click on it and it's going to pop open a window. Just type in the chat there. We're good. We're here. So just let me know. I'm going to wait a few seconds. All right. Awesome. Thank you, Mia. Thank you, Julian. So now we're here. So now we've configured DataJoint. We've told DataJoint, hey, connect to this database. We've said, this is who I am, and this is my password. And so, we had no complaints there. And so now we get to notebook 01. And so this is where the chunk of our session is going to be spent. So right now in this notebook, we're going to learn, 1, what a pipeline is. 2, we're going to create our first simple data pipeline in DataJoint. 3, we're going to insert some data into the pipeline. 4, we're going to use basic queries to flexibly explore the data pipeline. 5, we're going to fetch the data from this pipeline. And 6, we're going to delete entries from the tables. Just a quick note, in DataJoint, we've we use, or I'll be using in my presentation, the words pipeline and workflow interchangeably. They're synonymous. And so if you hear me say workflow, don't worry, it's the same as a pipeline, okay? So now that we're in a new notebook, we're gonna import DataJoint once more. So you can run this top cell. And so we heard Dimitri explain earlier what a pipeline is, and I just wanna reiterate or build up on what he said. And we have some text here. I'm just gonna pick out the main points of this text. So, you can follow along, but I'll be kind of summarizing and stopping and, elaborating on it some more. So if you visit the documentation for DataJoint, we define a data pipeline or a data workflow as follows. A data pipeline is a sequence of steps, more generally, a directed acyclic graph with integrated storage at each step. These steps may be thought of as nodes in a graph. So I'll read that once more. So a data pipeline or a data workflow is a sequence of steps, right? And more generally, it's a directed acyclic graph with integrated storage at each step. So of course, it goes in one direction. For us, it goes down, and you'll see more about, you'll understand that a bit more as we go through the tutorial. And so there's integrated storage at each step. And these steps may be thought of as nodes in a graph. So while this is an accurate description, it may not be the most intuitive definition. More succinctly, a data pipeline or a data workflow is a listing or a map of various things that you work with in a project, with lines connecting these things to each other, indicating their dependencies. So the purpose of DataJoint is to model your experiment, right? And it's to show how the different things or the different nouns in your experiment are connected. So these things in a data pipeline tend to be the nouns you find when describing a project. And these things may include anything from a mouse, the experimenter, equipment, the experiment session, the trial, 2 photon scans, electric activities, receptive fields, neuronal spikes, and even figures for your publication. And so a data pipeline or a data workflow gives you the framework to, 1, define these things in which you can store information about them. And 2, you can define the relationships, in particular, the dependencies between these things. So a data pipeline serves as a map that describes everything that goes on in your experiment, capturing what is collected, what is processed, and what is analyzed and computed. And that last part is very important because our workflow, DataJoint specializes in computational workflows. And you'll see more about that. We'll talk more about that tomorrow more specifically, but it's really exciting, and it's one of the main strengths of DataJoint, and it's what makes it so powerful. One of the reasons why it's so powerful. So a well-designed pipeline not only lets you organize your data well, but it can bring out logical clarity to your experiment. And it may even bring about new insights by making how everything in your experiment relates together more obvious. So if you do a good job defining your pipeline, you may even get new insights just by looking at it, the graphical output that DataJoint helps to provide. So now let's go ahead and build a pipeline from scratch to better understand what our data pipeline is all about. So we have a bit more text, and I'm only gonna read this top part, okay? Yeah, I'm only gonna read this top part, okay? But in your free time, of course, feel free to go back. Again, go back to the playground. We have our notebooks hosted there, and you can read through everything, with more time. And you can go back, kind of ruminate over it, think about it, drink some coffee. So let's build a pipeline to collect, store, and process data and analysis for our hypothetical single electrode recording. So for these next 2 days, we'll be focused on the electrophysiology. We won't delve into calcium imaging for the purposes of this workshop. So to help us understand better, or to help us understand the project better, here's a brief description. So your lab houses many mice, and each mouse is identified by a unique ID. You also want to keep track of information about each mouse, such as their date of birth and their gender. And as the hardworking neuroscientist that you are, you perform experiments every day, sometimes working with more than one mouse in a day. However, for any given day, a mouse undergoes at most one recording session. So that's very important, okay? So we know that our things, our entity, or nouns are going to be the mice and our sessions, right? And for each experimental session, right here, for each experimental session, you would like to record what mouse you worked with and when you performed the experiment. You would also like to keep track of other helpful information, such as the experimental setup you worked on. So we'll read this paragraph right here. And so in a session of electrophysiology, you recorded electrical activity from a single neuron, and you use recording equipment that provides separate data files for each neuron that you recorded. And your neuron's activities are recorded as raw traces, and neuron spikes need to be detected for further analysis to be performed. So over the course of the next 2 days, we'll be generating this workflow where we go from creating our tables to host our mice, to host the sessions, to host the neurons, and we'll even be able to see these neuronal spikes at the end of it. So extremely exciting stuff. So as I said just now, we'll be creating tables or things, right? We'll be creating tables to house information about our things, right? Which are the mouse, the experimental session. In the case of, for this workshop, we're using ePhys data. So we'll be talking about the neuron, yes, and the spikes. Yes. So it is very important. Yes, let me see. So in a DataJoint pipeline, we represent these entities as tables, and different kinds of entities become distinct tables, and each row of a single table in a single example is, yes, and each row of the table is a single example of the category of that entity. For example, if we have a mouse table, then each row inside that mouse table represents a single mouse. And when constructing this mouse table, we need to figure out how we're going to uniquely identify each entry. And so let's take the example of the mouse and think about what it would take to uniquely identify a mouse. So how do you guys think that we could identify each mouse uniquely? Oh, no, that's all right, John. So we're just asking, when you're creating, if you're creating a table to host information about all your mice, what do you think is a useful way to identify each mouse uniquely? All right, so maybe we can think about it for a couple of seconds. you can think about each of us right. Thank you, Mia. So you can do unique ID, genotype, all right. You can do, so sex and date of birth. Remember, we're trying to identify them uniquely, right? So if two mice were born on the same day, then it's not unique anymore, right? And let's say if you have 10 mice, 5 are male, 5 are female, then they're not unique anymore. But definitely the answer I was looking for, and thank you for providing it, is unique ID. So after some thought, we might conclude that each mouse can be uniquely identified by knowing its mouse ID, a unique ID number assigned to each mouse in the lab. And so the mouse ID is then the column in the table or an attribute. And so that's another, those are two words that you'll hear me use interchangeably as well, attributes or columns. And so the mouse ID is then a column in the table or an attribute that can be used to uniquely identify each mouse. Such attribute is called the primary key of the table. And so each table inside DataJoint has its unique identifier. And so that is called the primary key. Now, I want to stress that inside, does the ID have to be a number rather than, right? Thank you, John. That's a great question. So it can be alphanumeric. It can be simply numeric. It just depends on how you choose to define it. Thank you. And so I want to stress that in databases, when it comes to your primary key, you can have several different unique identifiers in one table. And so you can have several attributes, several columns making up that primary key. So for one table, you might have one single attribute being your primary key. In another table, you may have 3 different attributes being your primary key. But what matters is that these can uniquely identify your mouse, okay? Is that these are all unique and they uniquely identify your mouse as well as the table. So once you've successfully defined the primary key of the table, we can now think about what other columns or what non-primary key attributes we would want to include in this table. And so these are additional information about each entry in the table that we'd want to store. So for example, here we could say, yes, our mouse ID is our primary key. We also want to know about the mouse's date of birth and its gender, right? And so now we're gonna recreate this, or we're gonna learn how to do this inside DataJoint. But before we do, first we need to create what's called a schema. And so every table lives inside a schema, a logical collection of one or more tables in your pipeline. And your final pipeline may consist of many tables spread across one or more schema. And so so let me elaborate a bit on this. So for example, let's say that you have your mouse schema, for example. And in your first table, you have, your mouse ID, you have the mouse's date of birth and the mouse's sex. But as Mia said, maybe you want to know the mouse's genotype. So you may have another table that tells you the mouse ID, that identifies the mouse by its mouse ID, and it tells you its genotype, right? Or phenotype. And so you can have several tables telling you information about this mouse. And then after you have your mouse schema, you might also have, you might want to know information about the lab, for example, the rigs that are used in the lab, the experimenters in the lab, right? So all of these would be housed in like the lab schema. And then you might have another schema dedicated to electrophysiology, to the ePhys experiment, right? And so all the different steps, all the different data that got collected during that experiment would be housed inside that ephys schema. And then you see that these schemas are all, you can see how all the tables inside these schemas get related to each other. So we'll start by creating our first schema. And so now we're gonna type. And for the purposes of this tutorial, we don't need to, we're not gonna overcomplicate things. What we're gonna do is we're gonna use our username. So in my case, I'll use David Godinez _tutorial as the name of my schema. And the way we define a schema is we use dj.schema, and you put the name of your schema right there in quotation marks. So schema equals dj.schema. All right. And so we see that DataJoint, it didn't complain. So again, in this case, no news is good news in this case. Yeah, so, and I just want to very, well, this is something I'll, yeah, so as you import, this is just an aside, but as you import schemas, and you'll see more of it on day 3 with Tim, when he goes through a workflow, you'll see that your schema, whenever you're importing DataJoint, you also import different modules. And so these modules in Python are analogous to a schema inside the DataJoint, right? And of course, like I said, you'll see more of this on Wednesday. And inside each module, you'll have different classes defined, and each class will correspond to a table. So like I said, we'll see more of that throughout these next 3-4 days. So now that we've created our schema, mine's called David Godinez _tutorial. Let's just make sure it works. Right, so we can see that our schema has been defined. So now we can define our first table. And so in defining a table, you have a very specific syntax that DataJoint provides. And so the first thing that we'll do is we're going to use @schema. And this is equivalent to us saying, hey, DataJoint, I want to put a table inside my schema, in my schema called schema in this case. So if the schema had been called mouse, it would have been @mouse. If it was called ephys, we would have said @ephys. So this is us telling DataJoint where we want to place that table. And as I said earlier, a class corresponds to a table. So for those of you familiar with Python and programming, object-oriented programming, you define a class. And so you use the class keyword. And for this table, we'll call it mouse. So you say, hey, DataJoint, inside the schema, I want you to create a table called mouse. And this is going to be a manual table. Okay. And a manual table refers to a table where you can put information in manually. As we said earlier, DataJoint, one of its strengths, and it has many strengths, but one of them is that you can automate your workflows, meaning you can populate it automatically. And so some tables will have this manual definition where you physically, you type in information, metadata particularly, and some tables will be computed tables, right? Where you just tell it, hey, get this data from this directory, import it, you can do some computations on it, but we'll see more of that tomorrow specifically. So we say, hey, DataJoint, we're creating this table called mouse, and it's going to be a manual table. And so as we define the table, we use definition equals, and we use our 3 quotation marks. And inside our, yes. And so inside our multi-line doc string here, we can have, it's like, we can, this hashtag or optator experimental animals, this is further defining the table, and it's more so metadata about the table. It's not explicitly required, but since a big feature of DataJoint is that it promotes sharing, it's always important to give other users some idea of what this table is about. So we're saying, hey, this table is going to be about experimental animals. And then we move on to the next line. And so here we're saying the first column is going to be mouse ID. And we're saying that it's going to be integer. So John asked earlier if mouse ID has to be an integer. It doesn't, but you need to be sure to define that at the moment of defining the table. So in our case, we're telling DataJoint that we want mouse ID to be an integer. And here you can further give more metadata regarding each column or each attribute. So mouse ID is the unique animal ID. And I want you guys to pay very close attention here to our 3 dashes. And you can see that these dashes provide not only a visual separation, but what it does is it tells DataJoint that anything above our line here, or our lines, is the primary key. In this case, we have 1 primary attribute making our primary key, but we could have had 2 different attributes comprising that primary key. And so anything above this line is our primary key, and anything below it is, these are secondary attributes. So this table is identified via mouse ID, and we also want to define a column for date of birth. And we're telling it, when we say DOB equals null, we're telling it that by default, it's going to be null. And we're telling it that we want a date value. So we have date of birth. And then we have sex. And by default, it's unknown. And the data type that goes in here is an immune type. And this means, and in our brackets here, it can be male, female, or unknown. So it can only be one of those 3 values, male, female, or unknown. It defaults to unknown unless you change it. So let's define our table. Excellent. And now let's take a look at our brand new table. Beautiful. So we can see that we have our comment that we made here, experimental animals. We have our mouse ID. And you can see that as I hover over it, it tells us unique animal ID, which is our comment right here. As I hover over date of birth, it says DOB. And as I hover over sex, it says sex. And one of the many features that I love about DataJoint is that it conveys a lot of information visually. So you can see that mouse ID is bolded and in black, whereas date of birth and sex are not bolded and they're in white. And that's because the bolded black text refers to the primary key, and the white not bolded text refers to the non-primary key or the secondary key. So do we have any questions so far? How are we feeling? I got an error. Name DJ is not defined when I tried to create my schema. All right, so Julian, I'm gonna scroll to the top here. All the way to the top, you see this cell. You might want to run that cell. So
okay, got it. I think I forgot that one.
All right, cool. Thank you. So yes, once you run that one, then you can define your schema. Just let me know. All right. So I think no news is good news.
Yes.
So awesome. Thank you, Julian. So now that we've defined our table, you'll notice that while it is fun, it's awesome, we have our table is empty, right? So we need to put some data in there so that, to make things a bit more interesting. And so if you'll recall, we told DataJoint that we wanted this table to be manual, meaning that we'll be physically typing in the data for this table. And so we have two ways or two methods of inserting data. The first is called the insert one method, and the second is called the insert method. As you may surmise from the names, the insert one method is to insert one row of data, and the insert method can insert multiple rows or multiple instances. So let's say that we wanted to insert a mouse with mouse ID 0, the date of birth as 2017, March 1st, 2017, and a male. We would say we call the name of the table mouse dot insert one, since we're just inserting one entry. And inside the brackets here, we provide a tuple, okay, or a tuple. There are different ways to insert information, and we're starting out here with a tuple, okay? So inside this tuple, what we need to do is to position everything, put everything in the right place so that DataJoint can seamlessly, place this data inside the table. So for example, so here we have 0, then we have 2017, 301, and we have male, right? So let's say had I switched this around. So I'm gonna. So let's just say I got lazy and I forgot maybe. I was like, does date of birth go first? How does it go? So I get an error, right? And so it's important when using tuples to put everything in the right order. So let's see what happens when we put everything in the correct order. DataJoint doesn't complain. It says, okay, there you go. Now we have our first entry in our first table. So we have our mouse ID 0. It was born March 1st, 2017, and it's a male. As I said before, you could also enter data. You have several ways of entering data. So the first example we saw uses a tuple. This second example here uses a variable, which is a dictionary. Those of you who are familiar with Python, you'll know these famous curly brackets. And inside your dictionary, of course, there's a key and a value. And so we tell DataJoint that for the mouse ID key, we want our value to be 100. For our date of birth, we want mouse ID to be 2017, 5/12. So January, March, April, May 12th, 2017. And for the sex, it's going to be a female. So we define that data. And so you see, we inside our insert one brackets, we put data. DataJoint didn't complain. Awesome. So now we have our second entry. So this is mouse ID 100. It was born on March, April, May 12th, and it's a female. As I said before, we can use you can also enter multiple instances or multiple rows of data at the same time. And so the way we can do this is we can have a list of tuples. And so let's say we're entering a mouse at mouse ID 1. It was born on November 19. It's a male. Awesome. Put that in the tuple. Separate the other tuple by a comma, of course. So mouse ID 2, 26, November 20th, 2016. We're not sure of the sex. And our third mouse, mouse ID 5, born December 25th. It's a Christmas mouse. And it's a female. It's awesome. We define data once more. And if I try to do mouse that insert 1, I get an error, all right? And so if I just do mouse.insert, since it's multiple rows of data, DataJoint says, oh, okay, you wanted to put in multiple entries. In the same way that we could enter multiple tuples, we could also, in the same way that we can insert a list of tuples, we could also insert a list of dictionaries. So of course, same syntax as when we had the dictionary up here. You have your key and your value. And so we'll insert, and now our table is looking pretty good, right? So we have a whole bunch of mice. We know when they're all born, and we know their sex for the most part. Awesome. And so one very powerful aspect or attribute of DataJoint is its data integrity, the way that it checks for data integrity. And so this ensures that you don't insert a duplicate by mistake. So let's try inserting another mouse with mouse ID 0. So if you'll recall, that was the first mouse that we entered. So let's see what happens if we try to insert another mouse with a mouse that had that same primary key. So we see that DataJoint says, there's a duplicate entry for 0, right? Duplicate entry 0 for primary. And so we have this feature where you can use the argument skip duplicates equal true. So we can say skip. Oh, sorry, not there. Oh yeah, there. So we could use the argument skip duplicates equal true. So it'd be here. Skip duplicates equal true. And then if we do that, then DataJoint won't complain whenever we enter a duplicate. I don't recommend it unless you know that. So there are certain instances when you might want to do that. So for example, if you're kind of running everything again, maybe you have mixed data, like so you're putting in new mice and the data for whatever reason has mice that you'd already entered, and you're sure that you're okay with just kind of skipping those duplicates, then you can use this argument, okay? So now we're going to go ahead and insert a few more mice. So we'll enter our list of dictionaries once more. We see that our table is just growing. So I'm going to give you guys a minute or two to enter your own mice in, right? So of course, as you recall, don't use any of these mouse IDs, but I'm going to give you guys a sec to enter your own mouse. Practice using either the tuple syntax or the dictionary syntax. You can use the .insert1 method. You can use the .insert method. So you can put in a list of dictionaries or a list of tuples. And let me know how it goes. I'll give you guys 1 minute to do so. All right, we have about 30 seconds. All right, awesome. So I hope you guys had fun entering your own mics. And so now that we've created our first table, and now what we're going to do is we're going to create a table with dependencies. So congratulations, we've created our first table. And now we're ready to tackle and include other entities in the project into our data pipeline. So as a mouse, we should think about what information or attributes is needed to identify an experimental session. Okay, so here's the relevant section of the project description. So as a hardworking neuroscientist, you perform experiments every day, working with more than one mouse in a day. So we said this before, right? However, for any given day, a mouse undergoes at most one recording session. And for each experiment, you would like to record what mouse you worked with and when you performed the experiment. Okay. You would also like to keep track of other helpful information, such as the experimental setup you worked on. So based on the above, it appears that you need to know when you did the session, the date of that session, and the mouse that you recorded that session, right? So these can unique, as we said, one mouse can only have one session in a day. So these two attributes now can uniquely identify your table. And so these two primary attributes will comprise your primary key. Okay. And it says, note that to uniquely identify an experimental session, or simply a session, we need to know the mouse that the session was about. In other words, a session cannot exist without a corresponding mouse. With mouse already represented in our table, in our pipeline, as a table in our pipeline, we say that the session depends on the mouse, okay? So you can't have a session without a mouse. So now we're going to be creating our session table, and it depends on the mouse table, on the mice that are in the mouse table, okay? And so that's what we mean when we say it is a table with a dependency. We could graphically represent this in an entity relationship diagram, and I'll show you a more modern syntax that we've been using now by drawing the line between two tables. And so as I said earlier, DataJoint is one of my favorite things about it is that it's very graphical, it's very visual. And so we'll be able to see that relationship. Yes, so drawing the line between the two tables with one below session, depending on the one above mouse. And thus we need both mouse and a new attribute session date to uniquely identify this session. So now we define this new table. So again, we say, hey, DataJoint, I want you to put a table inside my schema called schema. Remember, if this schema could have been called mouse, it could have been called electrophysiology, right? So whatever you name your schema, and that's what you'll put here. And we'll define our second table. So again, tables are classes. And we'll call this table session. And this is also going to be a manual table. And as we define it, we say, so our first comment when we were defining the mouse table, we said it was the experimental animals or experiment animals. And this table is going to give us information about the experiment session. Remember, it's not absolutely necessary to put this comment here, but it's good practice, right? So that when other people use it, when other people use your workflow, they look at it, they can get a quick idea about what each table is about. And so this is our first clue that this table has a dependency. We see our arrow and we see mouse. So we know that mouse was a table that we had defined already. And this arrow tells DataJoint, hey, you're depending on the primary attributes. You're depending on the mouse table. And so whatever the primary attributes were inside mouse, those are also going to be primary attributes inside session. Okay. And if you recall, the primary attribute or the primary key was made up of mouse ID. So mouse ID is going to be a primary attribute here. But we also have another primary attribute called session date. And why can we use session date as a primary attribute? Why can it uniquely identify each session? Do we remember? So we know that each mouse is uniquely identified by a unique mouse ID. And why can a session date be unique to a mouse? So give us a couple seconds to kind of think back. Because you specified, right, you can only record, right, so thank you so much, John. So each mouse can only have one recording per day. Excellent, excellent. So now we've defined our primary attributes. We go to our secondary attributes, and we said that we would like to know information about the experimental setup, and that's going to be an integer. And our comment here is our experimental setup ID. We would like to know who the experimenter was, and this is a varchar of 100 characters. It has a limit of 100 characters. So if for whatever reason your experimenter has a name with 101 characters, then you're kind of out of luck. But of course you can modify this as you see fit. And you would also like the data path for the experiment, the data from the experiment, right? So you would save your data in some specific directory, and so you put that in this data path. And that is also a varchar, variable character, and we're defining this with 255 characters. So let's run this cell. Awesome. And it says you can so now inside our schema, we have the mouse table and we have the session table. So as I said earlier, DataJoint is extremely visual, and you can look at the relationship between these two tables using what's called an entity relationship diagram or simply a diagram. So you can call dj.erd. Again, this is slightly older syntax, but let's run it. Awesome. And now we have our diagram. And so we can see that we have mouse. And remember earlier we said that our workflow or data pipeline is an acyclic graph. So we see it running in one direction. In this case, it's going mouse session. And as we continue adding to our schema and adding to our workflow, we'll see that direction. We'll see it getting longer and longer, flowing in that one direction. You can think of it as water flowing through a pipe. It goes in one direction. And so as I said, you can use erd.erd or you can use .diagram. We get the same result. Diagram is just a bit more modern, is what we tend to use. So now that we've defined session, let's put some data in there. So we recall that we can use tuples, we can use dictionaries. So in this case, we're gonna insert one entry, session. So we'll say mouse ID 0. We'll say he had an experiment on the 15th of May, experimental setup 0. And our experiment was Edgar Walker. Yeah, so that's a great question, John. So I would, I mean, it is, but I don't recommend it because then, you'd have to go back and actually you would break everything. You would break everything. So the recommendation is that you think long and hard about how you want to define each attribute, right? The type of data that you want to put inside each attribute so that you don't go back and you're breaking things. For sure, that's a great question. Thank you. So now that we insert our data. Oh, sorry. So I got a duplicate error. I ran it just now already. All right. So excellent. Our session table now has our first session. So we ran an experiment on mouse 0. The session date was the 5th of May. The experimental setup was 0, and he was experimented on by Edgar. And since we don't have any data right now, we don't have data path, right? But this would be a data path. So let's add another one. And so now we'll use a different date. So we can see that as long as your session is being uniquely identified, you can use the same mouse ID, of course, but the dates have to be different, right? There has to be a way to uniquely identify each session. And so here we, in our second session, for mouse 0, he was experimented on almost a year later. He had a different experimental setup, and he was experimented on by Jacob. Oh, sorry, I ran that one already. And so now we're putting in another one, right? And we're just populating. And so I have a question for you guys. What happens if we try to insert a session for a mouse that doesn't exist? What do you think is going to happen? If we insert a session for a mouse that doesn't exist, what's going to happen? So for example, if we wanted to put a session for mouse 9,999, what would happen? Do you think DataJoint would say, okay, well, let's put it in? Right, awesome, John. So John's intuition is telling him that you would get some kind of error, right? Because we said that session is dependent on mouse. And if the mouse doesn't exist, how can you have a session for a mouse that doesn't exist? So let's see what happens. So we get what's called an integrity error, right? And DataJoint is saying, hey, cannot add or update a child row because basically it's saying this mouse doesn't exist, okay? So great thinking, John, thank you. So now we've learned how to create a schema, we've learned how to define our table, and we've learned how to define a table with dependencies. We've seen how to define manual tables. And we've also seen how to put in data using different methods and different data types. Before we move on, do we have any questions? We're right at that 1 hour mark. Do we need a little break or are we good? Please let me know in the chat if you guys want to take a quick 2-minute break to get up, get some water, stretch your legs a little bit. That's okay. Just let me know. I'm having fun. Short break would be great. Awesome. All right. So we're going to take a quick 2-minute break. For me right now, it is 11:54. So at 11:56, we'll be back. Okay. Thank you. And in the meantime, do we have any questions or any concerns? I'm thoroughly enjoying my time here with you guys. All right, so we have about a minute left. All right, we have a few seconds. All right, so we're at that 11:56 mark. So we can come back. I hope you guys got to stretch a little bit, got to get some water. And so now that we've begun defining our workflow, we've created our schema, we have our tables in there. The next step is you might want to query your data, right? So oftentimes you don't want all the data, but rather you just want to work with a subset of these entities matching a specific criteria. And so rather than getting all the data and writing your own parser, it's more efficient to narrow your data to a subset before fetching it, right? And we'll talk a bit more about this word fetch. So for DataJoint, DataJoint offers a very powerful yet intuitive querying syntax that lets you select exactly the data you want before you fetch it. And I really, really want to emphasize the fact that it is powerful and it is intuitive. It's amazing. I love it. It's one of my favorite parts about DataJoint. So we're going to be talking about three different queries that we can, three major types of queries that we can use inside DataJoint. So we'll be talking about the restriction query and the negative restriction. We'll be talking about the join, and we'll be talking about the projection query. Okay, so the restriction. So you can see that we use the and the point of the restriction query is to filter data with certain conditions. So the restriction operator and, or the ampersand, lets you specify the criteria to narrow down the table on the left. So let's say that we wanted to get information, we wanted to query information for a mouse or the mouse with mouse ID 0. So we tell DataJoint, hey, I want you to look into the mouse table and look into the mouse table, and like I told you, it's intuitive, and give me the mouse with mouse ID 0. You can see that the second part of our query here, it's in the string, quotation marks. So we tell DataJoint, look into the mouse table and give me the mouse with mouse ID 0. So we run it, and we see that rather than getting back all those mice that we had populated, we just get back the single mouse whose mouse ID was equal to 0. Awesome. Now, what if we wanted all the mice who were male? So we'll use the similar syntax. We say, hey, DataJoint, look into mouse, the mouse table, and give me all the mice whose sex is equal to M. Okay. You can see that M here is in an extra set of quotation marks, so pay attention to that. Whenever you have a number type or some type of numerical data type, you don't have to put those extra quotation marks, but if you have like an enum or a varchar, enum or like some type of string like this, you have these extra quotation marks. So we say a mouse whose sex is male. Yes. So now we got back all the mice who are male. And like we said, I really want to emphasize that this is intuitive, right? As you're thinking about the query, you can type it out. So maybe we wanted all the mice who are female. We do the same thing, but rather than M, we put an F. Awesome. And we can also use a dictionary as a restrictor. Okay, so with one field or multiple fields. Beautiful. So we say, hey, DataJoint, I want you to look into the mouse table and give me a mouse whose ID is equal to 5, right? And it's just telling DataJoint to format this as a dictionary. Awesome. Do we have any questions so far? All right. Sorry. John. Right. Thank you, Kavi. Thank you. Thank you. So Kavi, yes, Kavi has provided a great link to elaborate in the answer to John's question about changing the data type, mid workflow or mid experiment, as you're working through the experiment. Awesome. Thank you so much. So now, so you can look for exact matches, right? But you can also use inequalities in your queries, okay? So let's say that you wanted to look for a mouse that was born after the 1st of January, 2017. So you say, hey, DataJoint, look into the mouse table and give me a mouse whose date of birth is greater than this date of birth, than this date. And so we see that all these mice here, all their DOBs are greater than the 1st of January, 2017. And you can also query using a range, okay? And again, I want to emphasize that it is so intuitive. So you can say, hey, DataJoint, look into the mouse table and give me all the mice whose date of birth range are between, whose date of birth exists between March 1st, 2017 and August 23rd, 2017. So you can use inequalities, you can use a range, you can use exact restrictors. You can also use the not. Again, this exclamation mark equal sign, in Python that is not equal to. So you can say, I did it right, look into the mouse table and give me all the mice who aren't male. And so we see that all the sex are female, and we got unknown, right? Because we don't know if it's a male or female. Excellent. So these queries, they're intuitive and they're really they get even more powerful when you start combining them. And again, even the combination of these queries is really intuitive. So you can say, hey, DataJoint, I want you to look into the mouse table. Look into the mouse table and give me mice that aren't male and who were born after the 1st of January, 2017. So we run that. Excellent. So we can see that we get all female mice, right? Satisfying this first criteria. And we see that all the dates of birth are after the 1st of January, 2017. Awesome. We can do another one. We can say, let me see. That one's the same, but yes. So the result of one query another powerful thing that DataJoint has is that you can use the result of one query in another query. So I'll show you how to do this. So let's say if we wanted to get all the mice that were female, so you have your query right here, you could assign that to the female mice variable, right? So you run it and we're just gonna show this, show what's inside this variable. And so we get the results of our query right here. And so I'm gonna ask for your help here now. Oh, hey, John. Yes.
Yeah, I just I'm a bit curious about sort of the ampersand and the and as a text, because it seems like the two ampersands are actually different somehow. So one of them you can replace with and, but if you replace the first ampersand with and, it no longer works. So that to me that so in this 47 there,
Yes.
right, if I replace that first ampersand also with just and, you know, A and D, it no longer works like it does here. Can you explain? So you know what I mean?
So let me just, so like if you see up here, like it works. Oh, yes. So you notice that it works in both cells. So
Yeah, no,
up
I
here,
noticed that. Mhm.
yeah. And just let me make sure I'm understanding clearly. You're saying that you can't use and the ampersand twice?
Yeah, so this 46, 47 makes clear, okay, I can replace the ampersand with an and, you know, at
Right.
least the second ampersand, and it still works.
Right.
But if I do that with the first ampersand, it doesn't work. So to me, that
Right.
says that actually under the hood that these two ampersands are somehow different, but I don't understand
Right.
why.
Right. So right. That's a phenomenal question. Thank you, John. So you're right. It is implied that this is kind of like your, like you could say like your major restrictor. And so everything that follows this is after you've specified what table like you want to look into. Does that make sense? And so yeah, this is like the major restrictor, and this is a little bit minor. Does that make sense?
And you can only replace the minor one with it just with the word and.
Yeah, with the major one. Yeah. Yeah. But great observation. Thank you.
Okay, thanks.
No, thank you. So yes, so we have our variable, right, with this query for all the female mice. And so now I want us to look for all the female mice whose mouse ID is greater than 0. So how would we do this? And I would love for someone to type their answer in the chat. So I'll give you guys a few seconds to run it. And please type it in the chat once you have it. And then we'll kind of, well, I'll run your answer in my cell and we'll see. All right, so I have a few seconds. All right, Mia, thank you so much. Ding, ding, ding. Let's see. So Mia said we would use female mice and mouse ID greater than 10. Let's see. There we go. So we can see that we can use the results of one query here, right? And we can use that variable to add a further restriction. Excellent job. Thank you, Mia. And so just as a quick, oh, yes, John. Oh, John. Mouse and mouse ID. Let me see. Right. So the reason this didn't work, John, is because you have to put the name mouse ID in like the string. So you see how. Right. Thank you, Kavi. Exactly. You have to put mouse ID. Yes. Yes. But great question. Thank you. And so that's something I'd emphasized earlier, that whenever it's like the name of a table or a variable name, of course, you don't have to have quotes. But whenever you're using an attribute, then you put that inside these quotation marks. And if your data type isn't a numeric data type, then you have to put an extra set of the double quotation marks. Awesome. But hey, guys, I love it. Please keep the questions coming. Excellent job. And so another thing that DataJoint can do is that it can restrict one table with, do you have your hand up, John, or is it just as a result? Is it still from the last question? Oh, all right, thank you. So another thing that we can do is restrict one table with another. So we can say, hey, DataJoint, I want you to show me all the mice inside the mouse table that have a session. So we're using session to restrict mouse. So we see that the output is from the mouse table, right? The mouse table had those 3 columns. And we're restricting it using session. So we put in a data for in the session, and so these are the mouse who have a session. So mouse 0 and mouse 18. And again, we can further combine these restrictions. And so we can say, hey, DataJoint, I want you to give me all the mice who had a session who were male. And we just get one mouse, right? And we can see that this query is an extension. This query is an extension of this query. Oops. And we could also further extend it and say, hey, DataJoint, give me, give me the mouse who have a session date of, who had a session date that was before or equal to the 19th of May, sorry. And if you notice here, we have these brackets, and these tell DataJoint that session date, it's inside session. So our output is for the mouse table, right? We have these 3 columns, but our restricting query was everything inside the session table. So we could also use the negative operator as a restriction. So in the same way that the AND said, give me all mice who had a session, and you got that restriction, you could say, give me all the mice who didn't have a session. So we can run it. And so we definitely had more mice who didn't have sessions than mice who have had sessions. I guess we'll work on them later. But yeah, so that's how the negative restrictor works. And so now I want you guys, I'm gonna give you guys a minute or 2. And I want you to look for male mice that do not have any session. So male mice that do not have any session. And so I'll give you guys a minute, and please type your queries in the chat and we'll run it up here so we can see if it works or not. Yes. So about 45 seconds. Let's see who's going to be the winner this time. All right, Mia. All right, Mia's on it. So this is great. So let's see. So Mia said, we'll have, let's say, hey, DataJoint, look inside mouse. And of course, right? So mouse, sex is inside the mouse table. So we kind of close that part of the query off with the parentheses that didn't have a session. Excellent job. Is there any other way we could have run this query? Excellent job, Mia. Did anyone have anything different? Let's see. Hi, David. I got some others. Is it possible that I can access and go through them? Yes. So thank you for letting me know, Aditya. So a couple of things. This session is being recorded, and so we have our website, and it's where we have several different. We have quite a bit of an online presence. For this material specifically, you're able to go to our playground. And let me copy and paste that link. So you can go to the playground and you'll find these notebooks there. We're also recording this session. So in the near future, we'll have a playlist up. We'll have a playlist up for everyone. Yes. We'll have a playlist showing these videos, showing the session. Yeah, and please feel free to look us up on our website as well, datajoint.com. Yes. Awesome. But thank you for letting me know. Right. So Mia gave us, thank you, Mia, a second, an alternative to this first query. So let's see. So you could say mouse, look for all the mice that don't have a session, and sex is equal to male. Excellent. And you see that we get the same result. Excellent job. Thank you so much, Mia. So that's how we query using our restrictors, the and the minus. And now we're going to be talking about the join. Okay. So this is another powerful way to query inside DataJoint. And sometimes you want to see information from multiple tables combined together to be viewed and queried simultaneously. So I'll say that again. Sometimes you want to see information from multiple tables combined together, and you might want to query them simultaneously. You can do this using the join operation. And the syntax for join is the multiplication, the asterisks. And so the way it works is that it matches the common fields of the primary keys in the two tables. And it does a combination of the non-matched part of the primary key. And it lists out the secondary attributes for each combination. As a caveat, or as an aside, if two tables have secondary attributes that share the same name, DataJoint will throw an error. Okay, so when you join, if you have two tables with two secondary attributes that have the same name, you'll have to rename at least one attribute. So let's see how the join works. So we say mouse asterisk session. And excellent. So we see, if you recall, the mouse table had 3 columns, and the session table had a lot more, right? And so we see that it had 1, 2, 3, 4, 5, right? 5 columns. So we see now that we get a table, or we get a result that has 1, 2, 3, 4, 5, 6, 7 columns. So this is the combination of the mouse and the session table. You can see that, of course, you only get mice who have a session. So each row represents a unique and valid combination of a mouse and a session. The combined table can be queried using any of the attributes present in the join tables. So you can say, find experimenter Jacob. So find all the sessions where the experimenter was Jacob and where the mice were male. So we want to see the data for mouse from the mouse table and the session table. And we want to restrict it by Jacob as our experimenter and male as your sex. So you can see that we have one session where Jacob was our experimenter and the mouse was a male. Again, we can use our inequalities. So mouse in session, where the session date was after the 5th of May. Excellent. And we can see that session date is after the 5th of May, 2017. So these took place in 2018. Excellent. Do we have any questions on the join query? Let's see. Could you please share the link where these videos will be later? Yes. So Aditya, so right now it's being recorded by INCF officially, but whenever we do, whenever we get the link to the recording, I'll be sure to send it out to everyone. Right, and so Kabi has a great contribution here, thank you. So this is to further expand on John's question. Restriction can be done in a few different ways, including using the restriction operator, the ampersand, or with a string. So if restricting with the ampersand operator, you would use the following notation: mouse ampersand sex, not equal to m, and yes. And restricting by string. Right. Thank you, Kavi. Thank you so much. So now we move on to the proj restrictor, to the proj query. And we see that, so beside the restriction and the join operations, we have this other type of query, proj. And proj is used to select attributes from a table specifically. You can also rename, once you've selected these attributes, you can rename them, or you can create new calculated attributes. So let's look at an example. So let's say that we just wanted the sex. Remember, the mouse table has, let me run it real quick. So if we run mouse, we see that it has mouse ID, date of birth, and sex, right? But let's say that we only wanted sex, the sex column from this table. We run mouse.proj and we put sex. So we can see that, of course, we're always going to be shown our primary key, which in this case is mouse ID, and our sex. And our sex is what we wanted to see. And so that's what comes out. So note that proj will always retain the attributes that are part of the primary key. So we can also rename a column using proj. So the way we do it is, says we use the name that we want to give to the column first. We have an equal sign, and then we have the column that is going to be renamed. So we'll say mouse.proj. So if we wanted to rename the DOB column to date of birth, make it a bit more explicit, we'll say mouse.proj. We'll say date of birth is equal to DOB. So if you can recall, yes, DOB. Now we have this column as date of birth. We can also perform simple computations with proj. And so let's say that we wanted to find out the age of a mouse at the time that a session was done. So this is a very interesting one. And the way we do this is we can say, okay, so of course, if we want to find out the age of the mouse at the time that a session was done, we'll need information from both. We'll need the date of birth, right? And we're going to need the session date. So we'll say, hey, DataJoint, I want you to join the mouse and the session table. And I want to create a new column called age, right? And this age will be calculated by using the date diff, And for those of you who are familiar with SQL, you'll know this is something you can use. This is syntax that you can use in SQL as well. The date diff, the difference between the dates of session date and date of birth. So we run that, and we can see that we get mouse ID, we get session date. Remember, prose shows only the column of interest, right? And we get the age. So we named the column age here. And each row has its computed values, right? So mouse 0 was 75 days old when it did its first session. It was 320 days old, so almost a year when it did its second session. Mouse 18 was 259 days old when it did its session. Awesome. So now I want to get into, let's see. I'm a bit confused. I thought we just renamed data. Right. So that's a great question. That's a great question, John. So that the renamed column, it's what you call, it's not in place, right? So it'll be date of birth for that query. But whenever you, so it's just for that query output, okay? You can also do, if you can have it permanently change it by putting in place. And so that's, yeah, so using the in place argument as having the in place argument as true allows you to permanently change the name. Yes. But for right now, we didn't permanently change the name, right? So we call date of birth DOB for this query, but yeah, it's not a permanent change. So as you can see, the projection results keep the primary attributes from mouse and session, right? Joining in the joining operation while removing all other non-primary attributes. But maybe we want to see all attributes. And so the way we can do that is we put this ellipsis, these 3 dots. And what this does is that it tells DataJoint, show me everything, including this new column. So if we run it, now we get the combination of all the columns that are in mouse, all the columns that are in session, as well as our new calculated column. All right. So as you can see, it's really, the syntax is so powerful and so intuitive. Now we get into fetch. And so earlier, I said that I didn't want to get too much into the differences between fetch and query just yet, but now we'll talk about it a little bit more. And so a query is equivalent to telling DataJoint to just look for the data, right? So let's say you go to a bakery and you just want a slice of cheesecake. So you'll say, okay, let me look just for the cheesecake, right? You kind of filter out all the other types of cake and you just look for the cheesecake. Now, once you found that slice of cheesecake, right? Once you found what it is that you want, you can fetch it. And when you fetch the data, that's when you're downloading it to your local machine. And DataJoint downloads this as an array, okay? And so we're gonna see how to do that. So we're gonna query once again, and we're gonna say, hey, DataJoint, give us all the mice in the mouse table that are male. All right, so we can see that it's still in that table format. And now we're gonna fetch it. So we call .fetch on this male mouse variable here. So we say male mouse.fetch. And we can see that our data comes back to us. It looks different, right? We see that it comes back as an array. And so this array is a list of tuples containing the same information that was in the query. We also get additional helpful information. It tells us the data type of each of each row. It tells us, yeah, the data type of each row in that query, in that fetch. Okay. So we can also do this all in one step. So rather than assigning our query to a variable, we can just assign a dot fetch to the query itself. We see that we get the same information. And you can also fetch in different formats, right? So here we got it as a list of tuples. We can specify inside the fetch method. We can use the asDict argument. So now we get a list of dictionaries, if you so desire. And for our pandas lovers out there, we can even fetch as a data frame, right? So if you've used pandas before, this is going to be a familiar look. Inside the fetch, you can also specify if you just want the primary key for whatever it is that you're fetching. So if I say, hey, DataJoint, I want all mice from the mouse table that are male, but I only want their primary key. Right, so we see that we get a list of dictionaries, and we get, so mouse, we know that mouse 0 is male, mouse 1, mouse 19, and mouse 34. And we can also fetch specific fields. So let's say we want to assign the sex in the mouse table to a sex variable and date of birth to date of birth variable, variable. So we see that we get our array of all the sexes of all the mice in the mouse table. And we get an array with all the dates of birth of all the mice in the mouse table. We can do this together. All right. And in the same way that we had the fetch, the insert and insert one method, we also have the fetch and fetch one method. So sometimes you might only want one, you might only want one entry back. And so, or if you know that for sure you're only going to get one entry back, you can use the fetch one. So let's say we want to assign mouse 0. Is key the only attribute? Where fetch defaults as a dict. That's a great question, John. I think what we'll have to do, I'll point you to the docs up here. That's a great question. So I'll point you to the docs. And you can read a bit more about it. And so we can, yes. So let's say that, so in principle by default, yes, in principle, yes. Yes, great question. Yes. In general, you would get an array. Yes. And so, as we said before, fetch one does pretty much all the same things as fetch, just that it gives you one, one instance. Okay. All right. Awesome. Right. Thank you, Kabu. And so finally, we come upon the delete method. And the delete method, it deletes entries and their dependencies, okay? So now we know how to create tables, we know how to insert data, we know how to query data using our different restrictors or different types of queries. We know how to fetch this data once we've queried it. And now we're gonna learn about deleting the data. And again, DataJoint, as always, is super intuitive. So let's say that we wanted to delete mouse 100. we simply call the delete method on the query. So we say mouse and mouse ID is equal to 100, delete. And when we're deleting, DataJoint is going to ask us, hey, are you sure you want to delete this? And let's say yes. Awesome. So just for demonstration, we can see that we don't have mouse 100 anymore, right? And calling the delete method on an unrestricted table will attempt to delete the whole table. So it'll say, hey, if we delete all the data from the mouse table, you'll also be deleting 3 rows from the session table. So this is our schema, right? And this is the table. So you'll be deleting 11 rows from the mouse table and 3 rows from the session table. And we'll say, you know what? Maybe we'll hold on to it until DataJoint no. Let's just make sure all our data is there. Awesome. So the data didn't get deleted. And so guys, that is the end of our session. I have a couple of questions here, or a few questions. I'll delete this one. So, and I know we have a few minutes. So we'll do one. So let's say that I wanted to see a mouse with a session after this date. How would I query this? What query language would I use? And you can type your answer in the chat. So if I wanted to see the mouse with a session after this date, how would I query this? I'll give you guys about a minute more. So we want a mouse who had a session after this date. All right, so help you guys out. So we want a mouse, and let's say we wanted to see all the data, right? So mouse and session. And we wanted this session date to be after 2017 05 19. So that's how we could run our query. Okay. And we see that all these sessions took place after the 5th of May. Okay. Yes, after the 19th of May. And let's see here. I want to fetch the key for all female mice. How do we go about doing this? So if we wanted to just get the key on all female mice, how do we go about doing this? Oh, and I actually made a mistake here, I'm sorry. Yes, that's better. Sorry about that. So all these sessions took place after. So going back to one of John's question, right, regarding the quotation marks, yes. always put in the right quotation marks. And let's say you wanted to fetch all the keys for all female mice. How would we do this? So we'll give us a minute, see if someone can come up with it. Oh, thank you, Mia. All right. So, oh. Excellent, excellent. So these were all the mice that were female, and these are their keys. These are their primary attributes, right? The key. Excellent job. So with that, we wrap up, you guys, for today. Excellent job participating. I had so much fun. Let's see. Yes, and please, Kabi just posted some really great links. We have datajoint.com, datajoint.org. If you want to chat with us more directly, you can join our Slack at datajoint.slack.com. So please, we're always looking for people who want to use our framework. Always looking for people who want to include DataJoint in their experimental workflows. So thank you guys so much. We have another exciting day tomorrow. We'll be doing, we'll be using the make function, and we'll be learning about that automated or that computed part of DataJoint. And so you don't want to miss it. It's going to be great. So thank you guys once again. If we have any questions, we have officially we have about 5 minutes. We'll stick around for a couple more minutes. If not, we can end it. But I'll stop sharing my screen here. Or I'll keep it. Yes. So if we have any questions, concerns, comments. Thank you, Mia. Thank you guys for participating. Okay, it was awesome. And I look forward to tomorrow. So I think we could probably wrap up there. Thank you, John. We'll see you. Thank you, Julian. We'll see you. You guys are awesome. And we'll wrap up with that. Okay.
Thanks a lot, David. I will stop the stream now.
Sure. Thank you. Thank you, Pradeep.
And see you tomorrow.
Definitely. Definitely. Thank you.